A warm welcome to the session on Perform Speed Control of DC Motors by Field and Armature Control Method. At the end of this session, you will be able to comprehend and apply the information on a DC machine's nameplate, identify the DC machine terminals, connect the DC shunt motor using a 4-point starter and a shunt field regulator, start and run the DC shunt motor, measure the speed of the motor utilizing the shunt field control regulator, adjust the speed of a DC motor and determine how the field current and speed are related. Vary a DC motor's speed using the armature circuit resistance to determine the relationship between speed and armature voltage. In a 3-point starter, the no-volt release coil is connected in series with the shunt field circuit so that it carries the shunt field current. While exercising speed control through field regulator, the field current may be weakened to such an extent that the no-volt release coil may not be able to keep the starter arm in on position. This may disconnect the motor from the supply when it is not desired. This drawback is overcome in the 4-point starter. In a 4-point starter, the no-volt release coil is connected directly across the supply line through a protective resistance R. Figure besides shows the schematic diagram of a 4-point starter for a shunt motor. Now, the no-volt release coil circuit is independent of the shunt field circuit. Therefore, proper speed control can be exercised without affecting the operation of no-volt release coil. The only difference between the 3-point starter and 4-point starter is the manner in which no-volt release coil is connected. To identify the terminals of DC machine by using multimeter, select the multimeter switch to resistance mode. Connect the probe 1 at any terminal out of the 4 terminals. Connect another probe 2 at rest of the 3 terminals, where the meter reads that both terminals are identified as one winding. The same way, another winding can also be identified. By observing the both winding resistance, whichever winding is showing more resistance comparatively when compared to other winding, it is noted as field winding and to be marked as F1 and F2. Rest 1 is armature winding and to be marked as A1 and A2. In the terminal box, the motor windings such as armature field are marked as A1, A2, F1 and F2. As shown in the figure, give the connections to the respective terminals. As shown in the figure, turn on the DPST switch and the motor starts to rotate. With the help of a tachometer, the motor speed can be measured. The speed of DC motor can be varied using cut-in cut-out variable resistor and note down the field current. According to the readings, the relation between field current and speed can be noted through graph. Give the connections as per the figure using 4-point starter and choose the correct rated components such as rheostat, ammeter, voltmeter, DPST switch and fuse. These component values depend upon the DC shunt motor specifications. Speed, field current and voltages should be measured. Gradually raising the field control resistance automatically and decreasing the field current, record the values. Take the readings at different speeds and note down the values. Turn off the DC machine power supply. By applying the above values on graph sheet, the speed versus field current curve with the speed on y-axis and field current on x-axis, is drawn. As the resistance increased, field current is decreased, flux also decreased, but speed increases. Resistance decreased, field current increased, flux also increased, but speed decreases. By increasing the rheostat resistance, the field current reduces and we can observe the increase in the speed of the motor. Advantages and disadvantages of field control DC motor. Advantages: it is easy to use and manage at lower operational costs. This method typically consumes smaller amount of power. The field control method allows operator to obtain higher speed than the normal. Disadvantages: higher speed can result in less torque. Speed control of DC motor. Armature control method. Give the connections as per the figure with 3-point starter and choose the correct rated components such as the rheostat, ammeter, voltmeter, DPST switch and fuse. These ratings depend on the DC motor specifications. Maintain the armature circuit rheostat's cut-out setting. Apply the recommended voltage and use the 3-point starter to start the motor. Measure the speed, voltage across the armature and armature current and enter the results in a table. Gradually, raise the armature circuit resistance while monitoring speed, armature current and voltage across the armature. For each variant, repeat and note the values on a table. Turn off the motor power supply. By applying the above values on graph sheet, by increasing the rheostat resistance, armature voltage decreases and we can observe the decrease in the speed of the motor. Put on the graph, draw the speed and armature voltage curve with voltage on x-axis and speed on y-axis. Advantages and disadvantages of armature controlled DC motors. Advantages: armature control method, the field current and torque levels remain constant throughout the application. Disadvantages: more expensive when compared to field control method. Needs more power supply. Recap: in this session, we understood how to comprehend and apply the information on a DC machine's nameplate. Identify the DC machine terminals. Connect the DC shunt motor using a 4-point starter and a shunt field regulator. Start and run the DC shunt motor. Measure the speed of the motor. Utilizing the shunt field control regulator, adjust the speed of a DC motor and determine how the field current and speed are related. Vary a DC motor's speed using the armature circuit resistance to determine the relation between speed and armature voltage. Hope you have understood all the concepts clearly. See you in the next session with a new concept. Thank you.